Okay. Again, today we will introduce the virtual verification, and this is the uh, computational fluid design. Okay. Sorry. Okay. This is me, and I will just scroll down. So high levelly, we we are in step 2 here, and we are demoing whether we can do it. As last section stated, and we will design separate parts to introduce each section. And today we will introduce the CFD simulation. Today we only simulate the flow distribution of the vehicle. So firstly, when we import the 3D model into the CFD area, we needed to do some model simplify. Okay, so this is some very basic considerations. We need to make sure the 3D model are comfortable and easy for the ANSYS Fluent to read. Yeah. So the simulation tools version, we will use ANSYS Fluent 2024 revision 1. And also, if we use the right model, and then it will be economic for the computational cost. And we also, it's helpful to have a reasonable modeling and for the boundary setting, and there will be no abnormal, small or sharp corner, and which is very easy to lead to errors. Okay. So for for this case, we will simplify the 3D model. Yeah, we will use the same propeller, 4 propeller, and we will create the rotating area, 4 rotating area, and we will simplify the base. Yeah, the vehicle frame and a tripod, and in a very simple structure. Okay, and we will create a large space to simulate the environment. Okay, so here is the inputs review, and we need to provide the necessary information as we needed, such as propeller diameter. You make sure you select the right propeller and the right pitch, and we need to investigate our applications, and this is based on some simulation and some very annual calculation, and the revolution per minute. And also we needed to investigate the economical RPM, and we need to have a very clear axial distance and our payload and weight target, and also we need to have the cruise speed in mind. Yeah. Here, this is a guideline on how we do it. So again, we use the ANSYS Fluent 2024 revision R1. Yeah. So firstly, we open the software and click the fluid flow, and then drop it here, and then we double click the geometry, and when you open the software, there will be a design model. Then we click the file, import the geometry file, and then import you desired to import. And this step file is mentioned above previously, and it's a simplified model. Yeah, here is how it is like when we imported the 3D model. And before we do some operation, and we needed to do some preparation. For the four rotation area, we need to measure the position of the center of each center, and write down, change the name here to the right position, yeah, versus the global coordinate system. So this will be easier to update the setup information when we need to run the calculation. Okay, so here is the space, yeah, the overall space. Here is the rotating axle. Each one we will have we name it the rotating axle, but actually is the propeller, for propeller. Okay. So next one, we will group the interface. So we will click the tools and the name selection, and then we will select the space outer surface, yeah, or outer surface, and we name it alternate, and the software will identify this as the interface, as the alternate interface. Okay. So next one, we need to do some solid operation, and to make it easier for the software to simulate the results. This is based on the basic logic of this software. So we can create loading, and we need to combine all those 3D models. Okay, so the next one, we need to change the operation and use the subtract. That is select the space, and we will subtract all other bodies or all other parts, and change the preserve the two bodies, yes, and then click the generate. Okay. Again, the next one is the same operation, and we will select the 4 rotating area, and we will subtract the 4 rotating propellers. Yeah, okay, after generate. So we will complete the 2 booleans operation. Next one, we will do the mesh. It's very simple, and we can click the generate and the mesh. Then on the right, you can see how it looks like after we generate the meshes. Here, we can also set up the sizing. Just very simple. Quick click the mesh, right click the mesh, and set up the mesh size. You can set up the face mesh size and the body mesh size. Yeah, okay. And then the next one is after we mesh, and then we close, and then we go to this workbench, and we will open the setup and start. Okay, then we can go to this page. Yeah, this is the setup, page, we will do some general settings. We will do the zero condition settings. We will do the methods change, the control change, and the monitors. And after then, we will set up what kind of data we need to record, and also finally we run the calculation. Okay, so for the general settings, we will change the status to transient, and then we will set up the gravity, yeah, and also we need to change the units, yeah. For the angular velocity, we change it to ReV per minute, and for the length, we change it to the millimeter. Next one, we need to change the models and select the viscous, and we change it to the K epsilon, yeah. And also we need to change the rotation, yeah. Rotation propeller area, and we double connect this, and we select the mesh motion, and we set up the rotation axis position, and we set up the axis direction, and we set up the speed, rotating speed, velocity, and then we set the setting could be done for one, and for we also need to set another 3 propeller area using the same method. Okay. Then we go to the solutions, and in this, we will change here to the corporate, yeah. And then we go to the controller, we change the flow content members to 0.5, okay. And when we go to the monitors, and we will set up the residual, and we change the criteria to 0.01, and also when we double click the calculation, and we will create the export data format, and then we will select all the space, select all the data we needed, and click OK. And for after we click the run calculation, we can set up the time step we need to do, and also we can set up the time step sizes, and here we can leave it as what it is, and then we click the calculate, and after that we can get the results, but the results, it depends on how many your mesh, your element numbers, and also it depends on your machine, the computation power. Okay. So for go back to this case, we can see there is no interference for different propeller, and yeah, this is the streamline, and this is for the velocity direction. You can see there is no interface, and so it means the layout for the 4 propeller are acceptable, and there will be no impact to the drone stabilization. Okay, that's all for today, and if you need any original analysis model or 3D model, and just leave the message, and we will share to you. Okay. Yeah. So if you have any questions or any more support needed, or any more topic you would like to, or you are interested, you can check our social media and leave a message, and we will respond. Thank you.